Cool. All right, so yeah, my name is David Wells. I work at Serverless here. We're located in Soma. Come by and visit us anytime. We love visitors. Anyways, yeah, I'm a software developer. This is our team. That's me. I don't know. This is like going to go on our website, I think. I don't want it to, but yeah. Anyways, it's happening. Yeah. So who here would consider themselves a full stack developer? Most people? Okay. DevOps? Okay. Front end people? Anybody? Okay. All right. All right. We got some people. Who's running microservices in production? Okay. I came to the right meetup. All right. And who here has heard of AWS Lambda? Everybody. All right. Well, the talk's over. Thanks for coming out. Cool. Awesome. So, yeah, how many people here are like intimately familiar with one of these, or has ever had to, actually build a server? Okay. Okay. Or set up a load balancer, or do stuff with containers, which is really kind of the way to do things these days. Yeah. All right, awesome. So I got a little background about you guys. So let's begin. So before we start, like a quick, brief history of how we got to where we are today with how we do things with microservices. Back in the day, we'd build and maintain our own machines. I never had to do that personally, but it seems like some people in here had to deal with that. Then we would buy space in someone else's server farm. It was more, cost effective to do it that way. Then we would basically run virtual machines in the cloud. Everyone starts moving to this magical thing called the cloud. And then we're now in this phase of basically like when Docker was introduced in 2013, we started running containers in the cloud, which brought a huge leap where you could kind of just write how you want your box to be and spin that up wherever you want, spin them down wherever you want. It was a huge win. But I think, and I'm going to throw out a theory here, we're not moving past containers. They still absolutely have their place, but there's this new thing, and it's the hottest buzzword right now, which is basically building out microservices with functions, or AKA in a serverless fashion. So I'm going to talk a little bit about that today. So yeah, so AKA serverless. So this is the face that people usually make when I say that. Well, actually, this is actually what they say. They're like, what is this thing serverless? It's the stupidest word possible to describe this. Clearly, there must be servers somewhere at the end of the day. And that is true. There are servers. You've caught us. We're shutting down. Good night. No, there clearly are servers somewhere, but the point is the cloud providers kind of abstract that away from you, take care of all the provisioning, managing, and scaling for you. And then, yeah, I always throw this back when there's really people that are like, don't call it serverless. Is wireless internet really wireless? I can guarantee you there's a router somewhere that's connected to a wire that's feeding that wireless internet. So, and the other
less wires.
There are exactly. Exactly. And is the cloud actually a cloud? Maybe. Nobody knows. Jury's out on that one.
Yeah, really.
But yeah. So really, like quite simply put, like the whole serverless paradigm is running code on demand on a server that you don't need to provision, maintain, or scale yourself. Some of the largest tech giants out there basically are offering these function as a service platforms. So you have AWS Lambda, Microsoft Azure, IBM OpenWhisk, which is now under the Apache Foundation, and Google Cloud Functions. But why? Why are they doing this? It's basically like the paradigms that surround serverless. It really takes a microservices approach. So I'm glad I was invited here to speak tonight, where you break down your monolith into microservices. You break those microservices into functions. They're still grouped together as microservices, just like you would build out any one of your microservices today. But there's a lot of things that fall out of that. So like I mentioned, auto scaling, there's this concept of it being more event driven. So basically, instead of doing polling or some other methods, you can basically react to different types of events. And I'll get to that in a little bit and dive deeper in there. And the other huge win, as opposed to the other kind of like where we came from, is the pay per execution pricing model, which I'll talk a little bit about here as well. And it really opens up like a realm of new possibilities for how you can build things. And I'm going to show you guys some examples. And then this is then the reaction when I say all these grandiose things. What? This sounds like, fantasy la la land. Surely this is the latest hipster tech trend. But no, let's go ahead and break it down. So who here writes in Node or Python? Okay, Java folks. Okay, cool. So really, like when you're building out an application in a serverless type way, you really are just writing your code as you normally would. I write everything in JavaScript because it's eating the world. Run it everywhere. I love it. So you just write your code as you normally would in your language of choice. AWS Lambda out of the box supports Node, Java, and Python. Other runtimes are supported on other providers. I think Azure does PHP. Yeah. Anyways, there's a bunch of different runtimes you can do, and if you're writing Go, there are ways to shim other languages on AWS, so you can write in your language of choice, shim that down to Node or whatever. So you write your code as usual, and then you just deploy it up to the cloud in the function as a service provider of your choice, and then you basically only pay for that code when it actually runs. And this is on the per millisecond level. So basically, you don't have to pay for idle boxes. You can cut a lot of costs by kind of building out things in this way. Or if you have, a box set up somewhere that's running a cron job, you can literally only run that code when the cron schedule hits. And there's just some really big cost savings. I love this personally. This is why I got into this whole idea. Even before I worked at Serverless, I had all these side projects that, it's probably me and just my mom using, but I'm paying for these boxes monthly, and I moved everything over to Lambda, and I'm well below the pretty generous free tier of 1 million invocations a month. So basically I cut, I don't know, I think I was paying like $100 a month or something for all those boxes. And then the other piece, of course, which I mentioned, is like they'll automatically scale it for you. And really the way that it works under the hood is they are actually containers. So they spin up a container quickly on the request, handle that request, then that container kind of sits around. You're not being billed for it though. It's called a warm Lambda function. And then if any other request comes in, it hits that same container. Likewise, if there are like billions of requests coming in, they will go ahead and scale that out for you. So it basically, if you get like, a huge influx of traffic from Hacker News, or you're on the front page of New York Times, and people are hammering your APIs, you don't really need to stress about that. And that makes everybody a happy camper. It brings me to my happy place, at least, where you can really focus on your application logic and not, focus as much on the infrastructure side. Does it mean no ops? No, it does not mean no ops, which I'll explain in a little bit. There are some caveats to this approach, but it does mean for certain things less ops, and it basically gives developers the ability to provision their own stuff without having to go directly through, the DevOps channel. Yeah. So now people are like, yes, interesting. Okay, go on. This sounds cool, but I'm not sure about it. So the Serverless Manifesto, this was from a keynote given at AWS reInvent in 2016 by Tim Wagner. Basically, the manifesto is the functions are the unit of deployment and scaling. There are no visible VMs or containers in this kind of model. Permanent storage lives elsewhere, so these are stateless functions. Very similar to the previous talks. You put your state somewhere in the database or a Redis cache. Scales per request. So basically, users cannot over or under provision resources. I mean, if you looked at all the boxes running in your fleet and looked at what's over provisioned, there's probably some things that are over provisioned. I would almost guarantee you. Yeah, and then you never pay for idle, like I mentioned before, and they're implicitly fault tolerant because again you're offloading that to the provider of your choice. Yeah, and you bring your own code. That one's kind of weird. I don't know why that's on there. And yeah, metrics, and this is just an Amazon thing, but yeah, metrics are universal rights. I would remove that one too. I like this better. This is from a presentation given by this company called A Cloud Guru. Highly recommend checking this out. It's a great talk on this whole kind of paradigm as well. But basically, like I mentioned, it's about using that compute on demand service to execute your code. You write single purpose stateless functions, aka microservices. The design is push based, so things that happen, you can react to those and then trigger other things, and I'll get to that in a little bit. And then there's also this idea, and I'm very fond of this. I did a ton of front-end development back in the day. This is all about creating thicker client apps as well, because you can do a lot on the client these days, a lot, especially with service workers and all this other kind of magic happening in the browser. And then there's also this notion of offloading things that aren't your business's core competencies to third-party services. So like, it doesn't really make sense to create your role and auth service from scratch, especially when you're starting out as a company, or it doesn't make sense to roll your own transactional email service when there's a plethora of third-party providers out there, or text messaging, etc. So it's really like serverless is serviceful, if you will. Quote that and tweet it. Yeah. So like that, then the question is like, okay, cool. So all these providers offer a function as a service that I can, deploy my code up to, and then, ping it via an API or run it on a cron, or there's a bunch of different ways, which we'll get into how you can run that code. What does like serverless have to do with that? Like what we do? That's like the number one question I always get. And really, what serverless is, we provide an open source framework, CLI tool, to facilitate the deployment of your functions to the cloud. Because as you'll see, doing it manually is quite tedious. So yeah. So basically, it's your code plus the serverless CLI plus your provider of choice equals infinitely scalable paper execution microservices. Yeah, so it's all well and good. I'll get to some real life examples here in a second and some use cases. Yeah, so that sounds great. But how do we get there? We're seeing a glimpse into the future here. Let's get across that bridge. I don't know if you guys can see that same thing. Yeah. Anyways, I like to use like pretty pictures to illustrate points. Anyways, yeah. So how do we get from monolithic mountain here to microservice city? All right, I'm going back to the workshop with that one. I told you that wouldn't work, Nick. Yeah, right. I'm not using your jokes anymore. Just kidding, that was mine. All right. Yeah, so how do we do it? So you can absolutely do it. You can do it manually. So like this is how you'd actually do it, deploying via like the AWS UI. where basically you log in, you create a Lambda function, you write your code on your machine. If you're using any dependencies, you need to zip up that code, and then you upload that file. And then if you want to expose that to, let's say, the web, you have to go into API Gateway and then hook that up to an endpoint. And it's pretty tedious to do that. And if we're talking about microservices, you don't make one microservice and like, that's my company. You have a ton of services. So doing this manually is just, you're crazy if you try to do that. But yeah. So what does it actually look like? This is really bare bones project structure of what like a serverless microservice might look like, where we just have our code file. This is named handler.js. It could be named, foobar.js, whatever. And then we have a serverless.yaml file, which is the configuration. So what that looks like, the actual configuration, it basically says, so we're naming our service. So this is like our user service, let's say. And then we want to say where we want to run this. So in this instance, we're saying put this into AWS. The runtime is Node 4.3, which Node 6 actually just dropped yesterday. So yeah, woohoo! Yeah, so you can use like symbol and whatever. But yeah, and then like what code you want to run. So I'm defining the functions in my microservice, where there's a save user function in here, and then I'm referencing that handler.js file, which we'll see in a second. And then I have another function in this microservice that is, make a profile image thumbnail as the example. And then when we actually want to run our code. So I think I'm supposed to go to this screen to point stuff out. So basically, when we want to run this code, is we expose it to an event. So this one, for example, we want to run save user on an HTTP post. So when we actually deploy this, the CLI will spit us back a live endpoint where we can just post, use Postman to test it or plug it into our UI, etc. And that will then run the save user code. Likewise, down here, in this example, there's a function that uses just normal Node libraries to make a thumbnail. So I don't have code for this, but I would use Graphic Magic or something to take an image from a bucket and then resize it. And the event I'm actually responding to is when a new item is added to an S3 bucket. So you can basically trigger that function based off an infrastructure event and then resize the image and put it back into a bucket, like automatically without writing all of that application logic yourself. And there's a ton of other events that I'll get into here in a second. This is just the code real quickly for save user. So I'm just module.export save user, which is actually referencing that handler.save user. So when you export a named export, that's like the actual code that you're deploying. And then this is just using DynamoDB. You can use any data store that you want. Dynamo is just like inside of AWS, and it's super crazy fast. So that's typically what I go to. But yeah, and this is the function signature. This is what a Lambda function looks like. There's an event, there's a context, and then there's a callback. The event basically has all the headers and the body of the request that I read stuff off of. And then the callback basically sends the response back if it is a synchronous request. Cool. And then this slide is just like a bunch of people saying how they saved a bunch of money. I'll post these slides after the fact. Don't need to go into that. Now this is the reaction that the other reaction where they're like, oh, okay, oh, that's cute. You're running non-mission critical microservices as functions. We need battle-tested stuff. I'm not going to play around with this like untested, uncharted waters. It's my job. But there are tons and tons and tons of Fortune 500 companies using Lambda in production today. The two that I'm going to talk about real quickly is Nordstrom, which is a retailer here in America. Oh yeah, a lot of people know that. Okay. Uh, and then Coca-Cola, they sell sugar water. But yeah, so Nordstrom is using it for web backends. They're exposing their functions to HTTP endpoints. They're using it for a lot of DevOps automation, and then they're doing some streaming data processing as well. And they have a ton of functions in production right now. And we'll go into the DevOps automation piece in a second. But and then Coca-Cola is actually using it for marketing projects. So you don't have to return, like for your web APIs, you don't have to return JSON. You can return any format you want. So they return actually HTML back. So you can set up a Lambda function to, basically render a dynamic web page, and you don't need to worry about that scale. And that works very, very well for spiky traffic loads, like a, marketing blast. And then, yeah, a million other companies, a lot of other companies. The Serverless State of the Union, I would highly recommend checking that out if any of this piques your interest. And I'm not just a crazy person up here talking to you. Really cool to see like what's happening in the space. And then I'm not going to go into these examples. This was from the Serverless State of the Union. The Finra, they're like a financial regulation institute. They're like processing billions and billions of requests, all going through Lambda. And the guy actually he goes into it in like full detail. It's pretty interesting what they're doing at a very high volume. But yeah, so that's cool. But what about what can I use it for? What can I do with this? Pretty much everything. There are some caveats. I'll get to those in a second. But so these are the typical use cases that we see. So web and mobile backend APIs. So typically you might set up, Express server, respond to API requests. You could absolutely, put those into Lambda functions and respond, pull the data back from whatever, MongoDB or whatever you're using, and serve those requests. Form processing, which is pretty much the same thing. Image processing. So like I mentioned, the thumbnail resize example, that's a really easy one to describe because almost every app does that. But you could also do anything you put into an S3 bucket. So video processing, transcode this video into 12 different formats when a user uploads, video, and shrink it down so we don't have to pay for as much bandwidth, as an example. Web scraping and testing. So, and this kind of goes with the running binaries as well. So anything that you can run in Node or Java or Python, you can run in Lambda. So an example of that is running Phantom.js. You could go and do whatever you'd want to do with Phantom.js, which is a headless browser that can do things for you on web pages, or do testing for you, etc. I mentioned Coca-Cola is using Lambda to serve dynamic HTML. You don't have to. You can return, like I said, any file type. So there's some people using it to do dynamic image resizing. There was a really cool thing that I saw. It was a dynamic SVG for a GitHub badge. It's kind of a small thing, but you can do it with Lambda. Another really common use case, and I use it for this all the time, is a webhook listener. So every single SaaS product you use exposes all these cool webhooks, but I didn't want to set up a server to just sit around waiting for a webhook to ping it. So now I can just deploy a Lambda function. It can sit there idly. I don't pay anything for it. And when it gets hit, I get billed per millisecond. And again, generous free tier there. Cron jobs, I use it for this as well. So likewise, don't want to set up a server that runs a cron job every day that just sits around for a day and I get billed for it. DevOps automation. So Nordstrom is using Lambda functions to actually test their Lambda functions. So this is like Lambda inception, where basically when they deploy up an updated resource, they spin up a bunch of different Lambdas to do load testing, and then to check all of the kind of security permissions to make sure that everything's kind of locked down. And then, like I mentioned, there's infrastructure events, listening to new uploads to S3 buckets, listening to new items in a table. So, you know, a new user signs up to your service, they're added to your users table. That new user can trigger a Lambda function to send them a welcome email, for example. So you can see how you can start chaining all these things together to build a pretty robust application. Alexa skills, that one's fun, but yeah. I have an Alexa skill that tells me when my bus is coming. Yeah, and then IoT, and then bots. I really hate bots, but you can do it. Don't do it. Infrastructure events, huge list. I'm not going to go over all of these, but yeah, like I mentioned, the S3 bucket, DynamoDB, scheduled cron events, listening to CloudWatch logs. So if you know, people in your team are spinning up EC2 instances that don't have the correct permissions, you can basically have a Lambda watching that and turn it off automatically for you. Yeah, and you can listen to stuff on Kinesis streams, tons and tons of things. Almost everything, asterisks. And that's where I'll leave you tonight. Come to part 2. No, I'm just kidding. That'd be a good cliffhanger. There is a current limitation with Lambda, which is you can't run anything, you can't run a process longer than 5 minutes. So if you have, you know, some heavy machine learning stuff, like, or anything that runs longer than 5 minutes, I personally haven't written anything that runs longer than 5 minutes, but I know it happens. So in that case, you still are better off, you know, spinning up a Docker container somewhere. But you can use the Lambda function to spin up that container, run a long-running process, ping a Lambda function to return the results. There's a workaround. But yeah, and then another thing that can get you into trouble is if you chain too many Lambda functions together, you're like adding latency. So just be aware of that. But yeah, cool. So let's look at some actual examples. This silly toy app, I will admit, but this demonstrates what I've been talking about, where, you know, a user from the front end can upload an image to an S3 bucket that then triggers a Lambda function that then talks to recognition, which is another AWS service for facial recognition, puts an emoji on their face. Really stupid, but funny. No, nobody? Okay. Yeah, but it basically, I mean, you could use this for an actual thing where it's like, okay, I got to tag my friends or whatever it may be. This is a super simplistic backend API kind of setup. So you have an API gateway, pinging a couple different, you know, let's call them user CRUD functions, talking to a Dynamo table. A little bit more advanced. You basically, very similar though, you know, you have a front end, it's going through API gateway, it's talking to a couple of different Lambda functions, which one Lambda function is storing something into an S3 bucket, another one is actually sending a confirmation email and putting something into a Dynamo table. And this diagram, and yeah, it's from a company called Cloudcraft. If you're trying to plan out your microservice like architecture, highly recommend doing it in that tool because it makes pretty charts like that. And yeah, it's just very helpful anyways. And then here's another kind of example, which is pretty robust. And actually you can see that it's split into microservices. This is a company, or I guess they are a company. It's called Moonmail, where basically they recreated MailChimp just using Lambda functions. So they're offering this as a service, and they like insanely undercut the pricing of like MailChimp, like astronomically cheaper to use them over anything else. And I would almost guarantee that this business model is going to be replicated across every single tool that you use today. Someone's going to make it cheaper and undercut you. It's not always the best business model, but yeah. Anyways, yeah. So we have, you know, yeah, just basically a bunch of different things, and they're cross communicating with SNS messages. And another pattern that I wanted to show you guys that we use internally at Serverless is the GraphQL pattern. So who here has heard of GraphQL? Yeah. So basically, it takes a slightly different approach than REST, where you only have a single endpoint, and then you describe the shape of data you want back for your UI. It goes, and the server knows how to, basically the GraphQL server knows how to query for that data and return it in the same shape. So basically, we have an API set up, one endpoint that our UI uses. It talks to a single Lambda function that's where the GraphQL server is running. And then that kind of fans out and grabs the data from different places. But like what you can see here with this diagram is like we have, one team, which is, we're 11 people, so one guy, one guy right now working on this piece, the GraphQL piece. And then we have another team member who's more back-end focused, basically managing his part of the microservice. And then we basically a search team, if you will. So you can see how you can break these things into logical domains, and then they can be deployed independently of each other, which is kind of one of those microservice paradigms. Yeah, so it's not all rainbows, it's sunshine. There's no such thing as a silver bullet. I guess you can get a silver bullet, but never mind. There is no such thing as a technological silver bullet. There's a number of challenges in the space that mirror common problems you would have with a distributed system. So I'm just going to run through those real quick, and then we can open it up for questions. Unless you guys want to see a demo. All right. So service discovery is one of those. So, when you're breaking anything down into microservices, you need to know when things change, if endpoints change, are things still up, etc. So a lot of, the service discovery stuff is built into kind of those container orchestration layers like Kubernetes, or there's a couple of projects out of HashiCorp. But yeah, it's the serverless space. There are solutions to this, but there's nothing that we feel is perfect. So it's one of the problems that we're trying to solve. Another one, and this was talked about in the first talk, which was like managing secrets. So I still haven't really seen like a blessed way of sharing secrets. There are some services out there that help you with this, but we're running into this ourselves. So we're kind of trying to solve this problem as well. But basically, when you're working with within a team, how do you share those secrets? Obviously, you want to put them in your environment. But yeah, and we're using like a whole like CI/CD pipeline, encrypting keys with like custom scripts, and it could be nicer. And then logging. So you do get logging out of the box with every single Lambda function. It just comes with your when you deploy your Lambda function. So you can forward debugging, what have you. But when you're chaining together different function calls or going across services, like stitching those logs together can be hard, but that's kind of how it is with every kind of microservices approach. And we are seeing this like really cool, I think you mentioned the like event-driven paradigm. We're seeing a lot of people kind of move in that direction. There's a really cool project by Nordstrom actually called Hello Retail. It's in the github.com/Nordstrom/Hello Retail, where basically they took, this is a demo application, but they're working on basically exposing all of the events that happen in their like entire business, centralizing that into think like a Kafka-esque log, and then reacting to those events. So like when new product, items get added to the product catalog, the marketing team can react to that and do whatever. There's a really great book I highly recommend, I Heart Logs, by the guy that wrote Kafka. He talks about why they developed it in LinkedIn. and what it can do. Yeah. Cool. And then, yeah, stack tracing, it's an issue with any distributed system. There are some tools out there. Amazon has one called X-Ray, where you can kind of trace through the different calls to the different infrastructure pieces. They also have a thing called step functions, where you can basically write your logic of how you want your functions to interact and like do branching logic. You write it in JSON, and it gives you kind of a nice pretty graph, and you can see where anything fails through the execution. There's a company called IO Pipes that they do a lot of metrics around your Lambda functions. You have to instrument your code to do that. And then there's a heavy bit company. We're working out of heavy bit right now called Lightstep, similar for distributed tracing. But yeah, like the main thing right now is like your code must be instrumented, and I don't like that, but I don't know if there's a way around that. So maybe one day. And then, yeah, the last thing is cold starts. Like I mentioned, if the Lambda function hasn't been pinged in a while, it needs to boot up. So this can add a little bit of latency, but there are ways to kind of get around this. One of those ways is to basically ping your Lambdas on a cron. And there's actually a serverless plugin that lets you do this. Like the CLI is pluggable, so people will write plugins to do different kind of use cases. It's called Serverless Plugin Warmup. But yeah, so definitely like test everything, make sure it's fast enough. Yeah, I don't really see this as an issue personally, but I mean, it's still out there in the ether. And I use a lot of UI loading states if there is a cold start, so the user doesn't really know. Yeah, so if you laugh in the face of danger and like solving hard problems, like this young industrious lad, we're hiring. So if any of those things that I described are like, wow, that sounds cool, check it out. We'd love to have you. And do you guys want to see a demo?
Yeah.
How much time do I have?
We are overtime.
Oh, really?
Yeah.
Okay. I'll just play the video real quick while they're listening. Yeah.
Ooh.
All right, questions, but this is the demo.
Wow.
So serverless deploy. So the framework is basically taking that serverless.yaml, reading all the functions and the events that trigger them. In this case, it was just an HTTP endpoint. So it deploys it up and gives us back a live endpoint to hit. And then you can just curl that. That's like an infinitely scalable like endpoint. That's the short demo that I don't have to like.
Yeah.
Yes.
How did your Mooney Bus app get an event whenever the timing updates? You just do it on a cron?
Oh, so the bus, like when the bus.
That you're talking about.
Yeah, so that's just an Alexa. It's actually an open source. If you just Google Muni Bus, I didn't write it, but I use it. So it's just a Lambda function. It's written in Node.
Yeah, what's the event? What triggers it?
Oh,
What
it's just an HTTP event, or actually, I think it's just plugged in. There's an Alexa event that it's a custom Alexa skill, and you say, "Hey Alexa, when's my next bus?" And that can then take it can take the function ARN and trigger that function. Okay. And that's just Node code that goes and pings the Muni API, which returns XML. And yeah.
That's fine. I thought it was while you were sitting there having your morning coffee. It was just letting you know periodically.
Yeah, that'd be cool. You could do that. You could honestly, the use cases are, endless, up to your imagination.
So you might have answered this with the keep alive stuff, but like, you don't have any control over locality. Different things working together, like even simple stuff like connection pooling. Can a Lambda function have an open connection to Dynamo and so you can reuse or data store?
So when you're connecting to Dynamo and the code that I was showing, you make the connection outside of the actual function, and that will stay open. So if that function gets hit again, it'll reuse that connection. But if you put it inside of the actual function, it'll connect every time.
Well, if I have have a dozen functions that are part of my API, and they're all using basically the same tables. This microservice has 3 functions.
Yeah.
Those are all going to be in different containers, and they can't share a connection. I need to keep all of those Lambda functions alive, or?
I make my database connection in a lib. Like I write it. Let me show you the code real quick. Serverless scope. Yeah, all the stuff we do is open source too, by the way. So if you want to check out any of these projects, back in. This one, it actually has like 5 functions. What's that? Oh, oops. You just gotta believe me, man.
Yeah.
Okay. So yeah, this basically has like 5 functions. I'm just importing them from a lib folder, but I have one database, basically util, and I connect to the database. And if it pings the same Lambda function, it will reuse that. And this is Dynamo, so it's in the same exact data center. That's the other thing. You can deploy Lambda functions to any of the AWS regions that Lambda is supported in. And then, yeah. There's a question back there.
Just remember you mentioned price models and you were saying per request, having you said something about milliseconds, then you said less than 5 minutes. So is it less than 5 minutes?
5 minutes is the limitation on how long you can actually run something. Your Lambda, it'll just fail.
If you run 4 minutes, 9 seconds, that's what.
No. That's per millisecond. Yeah.
Okay. So it's one request.
Yeah. So you're right.
You were kind of, I was watching you join your state.
All my requests are real fast. That's why I say per request. But yeah.
Per millisecond.
Yeah, per millisecond. Yeah.
Per millisecond of open requests. For example, I could do asynchronous work outside of a request lifecycle. How does that really work?
It's as long as like that function is waiting for the callback, it's running. I do believe. Yeah.
Is that limitation like AWS Lambda limitation, serverless limitation, time limitation?
Oh yeah, that is a provider thing. So every provider has that kind of limitation. The cool thing is that all these providers basically have the exact same free tier, so you could literally just like use all of them and do a bunch of stuff for free. Obviously, if you're running stuff in prod, you can't do that, but yeah.
Are you guys, is the CLI, the library frameworks, trying to support like a least common denominator, multi-cloud sort of thing?
Yeah,
or?
so that's exactly what we're trying to do. It's basically an abstraction layer across the different cloud providers where the events are very similar, and the code is also very similar, but you just define where you want to deploy to. You have to have your credentials set up and what have you, but cool. And there's one more thing I want to show you guys real quick, which was this right here is the examples. Almost all the use cases that I mentioned, we have like the code you can go read, deploy to a dummy AWS account, play around with it yourself. And feel free to reach out to me if you have any questions or ever need help or want to come visit us. We love visitors. There's free lunch at where we work. Greg took advantage of that the other day. Yeah, cool. Thank you.